Awesome. Welcome everyone to this session. I'm so happy to see such a large crowd today, ready to learn about Microsoft Purview. Today, our session is about data security and Microsoft Purview. My name is Yangchen, and on stage with me is Tom. We're both product managers in the Microsoft Purview team, and we're excited to share with you today how data security can actually help you, especially in this world of AI. We'll start today with setting context about what we've done with Microsoft Purview and AI apps. We'll deep dive and expose that stack to you to show you how our technology actually makes this happen. We'll demo this in a sample application made with the Purview value that you see today and leave enough time at the end to answer questions so that you can use this presentation as your reference point for building AI applications. So, why should you care? The first thing you need to understand is, as organizations build AI applications, security becomes really, really important. Your CISO is going to block the release of any AI application where the security standards are not up to mark. So, how do we solve this problem of building security into AI applications? We must first acknowledge that as a developer, you face challenges from across the pipeline, from building your application to the actual deployment and monitoring. And let's be honest with ourselves. With the pace of AI today and shipping at the pace of AI today, for any challenges that we don't have solutions to, us developers, we take shortcuts. And that's not going to cut it with the kind of power that comes with AI. So let me ask this framing question. What are the tools that we're going to make available to you as Microsoft to address these challenges? The way to think about our entire stack is, if you use the Microsoft stack, it is integrated with security, safety, and it is also trustworthy. Our combination of 3 services is what helps you get here. We have Microsoft Purview for data security, Azure AI for AI safety, and Microsoft Defender for Cloud for app security. Now, there's a whole lot to cover in this space. So today, we'll focus on Microsoft Purview for data security and how we can bring data security to your AI application. Let's take a look back at the challenges framework we introduced earlier and dive a bit deeper. How does Microsoft help you with data security and compliance for developers, for end users, and for enterprise? As you, the developer, build your application, end users are using these applications, and there exists IT admins whose job it is to ensure that the enterprise continues to be secure while your application is in use. You have 3 personas to take care of: yourself and 2 others. So as we go into each persona into greater detail, we want you to take away that Purview helps across this entire stack. Now, you must be curious, what does Microsoft Purview provide you from a value point of view? The core thing that Microsoft Purview helps you with is data security and compliance. We accomplish this through 3 pillars. We discover AI risks, we protect sensitive data, and we govern AI usage. It's through these 3 pillars of value that Microsoft supports the 3 personas: you as a developer, the end user, and the IT administrator that is actually running these solutions. Now, we made this value happen when we built Copilot for M365, our flagship Copilot, which we released in November of last year. On day 0, our Copilot was integrated with Purview to have security, compliance, privacy, and responsible AI. Now, why is this important? Because at the end of the day, what I want you to envision here is replace M365 Copilot with your own AI application. And your AI application, by using the power of the Microsoft stack, has from day 0 security, compliance, privacy, and responsible AI. Let's take a deeper look into the value that we had in Copilot for M365 at GA. We have 5 solutions that we covered. We covered information protection, audit, communication compliance, e-discovery, and data lifecycle management. Now, out of all of the solutions that we have in Purview, why did we choose these 5? We chose these 5 solutions as the core solutions because when we spoke to customers, we learned that these are the solutions required for enterprise adoption of Copilots. And that's why I want you to focus on these solutions as the baseline for when you develop your own AI applications. I'm going to dive deeper into what it looks like to implement information protection, starting with protecting a Copilot-enabled application with sensitivity labels. We brought this type of information protection value to Copilot for M365. And in it, we have label visibility, we have permissions enforcement, and label inheritance, all powered by the familiar sensitivity labels in Microsoft Purview. Let's take a look at what this might look like in a chat application. The first thing you should notice here is after we submit a prompt, labels are front and center for your end user to see the sensitivity of the content that that Copilot is accessing. Here, in the context of the current user, if the current user does not have access to see the content, we perform the right access check to ensure that the Copilot does not summarize this data. And with all of these AI-generated artifacts, these outputs from Copilots, we ensure that we inherit the highest sensitivity label of the content used to provide this AI-generated response so that your responses are properly labeled. Now, we've covered a lot of ground here today. What I want you to understand, or your main takeaway, is that you should use Copilot, this reference of Copilot for M365 and Microsoft Purview as your reference point for building security and compliance into your AI applications. This isn't just to mimic the work we've done here, but also to recognize the amount of heavy lifting and due diligence we've done to vet what is important for end users and admins that are using and monitoring your AI application. Now, to leverage all of this Purview technology, what are the tools that you need to get started? APIs. This is where I'll introduce the Microsoft Purview Information Protection SDK. For information protection, the MIP SDK is what enables your application to become aware of labels, permissions, and the rest of the Purview goodness. When an admin in the Purview portal configures their labels, your application, through the MIP SDK interface, is able to pull and expose the label and permissions in the Purview backend so that you can surface this in your applications. Think of the MIP SDK as your key to integrating Microsoft Purview into your AI-enabled applications. Now, the MIP SDK is composed of 3 components. Chances are, unless you're diving deep into the protection stack for the protection SDK, or deep into the details of labels with the policy SDK, for applications that are reading and writing sensitive data, you want to use the file SDK. The file SDK helps your application understand and modify labels. That means performing the full suite of label operations, from changing a label, applying, or deleting a label. With protection, your application understands who is allowed, who has the permissions to read the data. And this is all handled for you by the MIP SDK. In the following section, I'm going to hand this over to Tom, who will demo a sample application made with the file SDK so that you can see the information protection value in action.
Thanks, Yangchen. Excuse me. I guess there's one more slide. All right, so we'll demo a sample application. Let's just switch to Visual Studio. That's meant to simulate this pet store application. So what we've built here is this back-end admin application that's supposed to be like a customer service portal for a pet store, online pet store. So it's not our front-end shopping cart. It's not anything our customers use. It's for our customer service reps to, or product reps to set product prices, look up customer information, find out about people's pets and that kind of thing. So if we quickly go through this, you'll see that there's a bunch of products in here. All of these are Azure OpenAI generated. Just make some funny results. We've got some customers. We've got a list of pets. And we use all of that to generate a bunch of orders. And then from there, we get into chats. And chats are really the core of this demo and how we're going to use generative AI to help our chat representatives better understand the customer's posture, right? I have to call somebody. Well, I want to find out what cases have they opened? How happy or sad are they about our service? And we can use this Copilot that we've built to get a summary of that information. So we'll dig into some chats, and there's some things that we'll highlight along the way here. So I'm this customer service rep. I'm logged in as Alice, and I'm just looking at all of the chats that our customer has available or that they've had with our customer service reps. And we'll dig into one of these. So a few things right away you'll notice. First, we have this label column. So what we've done as part of our application is we've integrated with the Information Protection SDK to apply sensitivity labels to this information in our database. And very quickly, if we look at the database for this application, obviously a sample, it's just a SQLite database. But there's a table that has chat messages. These are the raw messages. And then there's a label associated with each of those. And we can manage that based on the type of information we're logging. So in the case of our application, we have confidential all employees, which is like anybody in the company can access this information. And then we have some more sensitive content here. So we've got this one file or one chat that's labeled highly confidential restricted label. Going back to the Copilot example, this is where, as you're asking for summaries of documents, let's say in SharePoint, it's going to flow those labels through. You're going to see, oh, you referenced the highly confidential document. You referenced the confidential document. And it'll make sure that we enforce those controls. So this, you can imagine, is similar to having data in some other repository, like SharePoint Online. The next thing you'll notice is that Alice doesn't have rights to view this content. So based on the label, we can actually restrict access to that content based on the user who's trying to get to it. So she's got this chat here that contains some information that's restricted, and her access has been denied. So now we jump to the Copilot we've built for this. Again, we want to be able to summarize information about our customers and give our customer service reps a heads up or an idea of what to expect as they engage with a customer. So we'll summarize information for William Kim. Now, I've heard there's some issues today, so hopefully this works. And some things are happening in the background. So we're taking all of that data out of our database. We're passing that off to Azure OpenAI, and we're getting summaries of that. But before we do that, we're checking access. So we're making sure that the source chat, does the user have access to extract information from that chat? We generally refer to that as checking for extract rights. And we want to make sure that I'm not generating any outputs that contain information that I shouldn't have had access to or that I don't have access to extract information from. So you'll see we get the output. And there's a few outcomes here that are important for your application to mimic what we've done with Copilot for M365. The first here is the sensitivity label. So one of these chats was highly confidential, and we've inherited that label from the chat to the summary output. And the result is that we can make sure that artifacts that we're generating are getting the same level of protection as the artifacts that they were generated from, which means we can apply like view rights or extract or prevent print, save, that kind of thing. And I don't have a user who's using this to maybe find information and summarize information they ordinarily shouldn't have access to. Next, you'll see we get the summary. And at the end of it, there's this line that says, sorry, I can't summarize the chat with item 127 as this would violate security policies. And this is, we'll show how this works in a minute as we get into Visual Studio. This is also similar to Copilot. As you try to ask Copilot to summarize documents, if it finds something that you don't have access to, it'll tell you that. It'll say, hey, there's this other thing you should check out. And Yangchen showed that earlier in the slides. And finally, there's the references. So this is just a table of all of the chats that we looked at. And as we scroll through this table, you'll see that most of these are confidential all employees except for chat number 127, which contained restricted data. And earlier we had looked at another chat with an example of this that showed that Alice doesn't have rights to view this. Therefore, we should redact it from going to the LLM at all and being summarized because we want to ensure that it doesn't end up in the output that Alice asked for. So now we'll switch over to my other test account. And we'll do that same thing, but we'll do it with breakpoints enabled in Visual Studio, and we'll dive into how we actually do this in code. All right, refresh. Great. So we've hit the first breakpoint, and that was right at app load. So the first thing we do here is we use the Information Protection SDK to fetch labels for the user. So we make a call to the service through the SDK, and we get all the sensitivity labels related to that user, and we store them in a representation of that label that we call sensitivity label that's part of my application. Contains things like color, description, display name, the label GUID, and then parent labels, so we create that parent-child relationship. We'll store this in the database. Again, jumping back to the database, you can see that there's a whole bunch of labels that are in here with that information. And we'll reference those throughout the application. So we continue on. Now we go and we look at some chats. So this is the one we looked at earlier that had highly confidential information, this chat with 𝗦𝗲𝗀𝗻𝗂, and we've hit our first breakpoint in the application. So I mentioned that we want to check that the user has rights to the data that they're trying to access based on the label ID. So a bunch of these chats are either labeled confidential all employees or they're highly confidential restricted data. So for each one of these chats we look at, we're going to check the label ID. And we do that by calling this API we built called hasViewRights for label ID. And if we step into that, you can see that what we're doing here is actually calling the Purview Information Protection SDK. And we are checking the user's rights on a specific label. We're going to skip over the internals of the SDK because we've had other talks about that I think are in the resources. But we'll jump into what this API does. So inside of the SDK, there's this get rights for label ID. And it's pretty simple. Pass in a label ID, authenticate, and we'll give you a list of rights for that user. And what that looks like is a pretty simple list of strings. And so as somebody implementing this application, you would, in this case, we're checking for the view right. We want to make sure, does that thing contain the view right? If it does, great, let them see that content. Later on, we'll look at the extract right, and we'll come back to that one. There's two exceptions you might encounter here, which is a no permissions exception, which means the user doesn't have rights to that content at all, so handle the exception. And we return false in this case. We say, well, if I got a no permissions exception, they must not have access, so return false. And then if it's label not found, then it's probably not encrypted to start with, or it's probably not protected, so let them view the data. And we will disable We'll go ahead and we'll disable this breakpoint. And we'll move on. So now what happens in the application is for every one of these chats, it's performing that check, and it's saying, does the Tom test user have access to this data? Now, the difference here between what Alice saw and what my account sees is this item is not redacted. I have access to this. So when it got to that view check, the result was true. I do have access, and I get to see that item. And you can see in this case, we marked it as restricted because it contained a credit card number. So again, that's like a view level protection that you can apply just to protect things at an item level. We do this across the comparison in M365 is files in SharePoint Online that have sensitivity labels. We check that label before Copilot's allowed to summarize it at all. And then we check the extract right also. So next, we'll go over to the Copilot. So here we're going to look at William Kim again. We'll summarize William's chats, but this time we'll dig into the code and how each of these steps is analyzed. So I mentioned the extract right. Now this is slightly different from view. As a user, I might have access to view some data, but I'm not supposed to have access to like take that data out of the system. Comparing this to the M365 side of things, if you've ever seen a labeled document that has restricted rights, you might not have access to take a screenshot or to save it or edit it. This is that same parallel. We want to make sure that a user who can't extract information from that document opened in Word can't use a Copilot to extract that same information, because that would bypass the security control. So again, the same thing here. We're just calling the hasExtract for label ID method. That's going to call that same API we looked at earlier, return a list of rights. We'll check to see if the user has extract, and if they do, we'll allow this to be part of the summary. So this function is actually iterating through all of the customer chat conversations, all of the messages that are part of those chat conversations, building a prompt, and then checking each of these to verify that the user has extract. Log a debug message. So the next thing we need to build, going back to the example with Alice, is that references table. What we'll do here is we'll start to build a referenced message ID. This enables us to build that experience where we point back to the original message. We'll build that is redacted, so if the user doesn't have the extract right, we'll say that we did redact something here. And then finally, we'll use the sensitivity label ID, and that's just to build the UX that shows the label in the interface. We add that to the list of references, and now we get to calling Azure OpenAI. So in this step, we're going to build the chat summary. We have our original text, which we'll store as a prompt. And we need to create the summary. So here what we're doing is we're checking for the extract right. And if the user has extract, we'll actually call into our OpenAI service. And we're going to ask it to summarize the customer conversation for this customer for this prompt. Again, we built the prompt back up higher. If the user doesn't have extract, so if this evaluates to false, we're just going to make the summary say, sorry, I can't summarize this message ID. And that'll build the experience you saw with the Alice demo, where at the end of the message it said, sorry, I couldn't summarize this specific message for you, which at least gives them some indication that the data might be incomplete based on what I'm allowed to give you. We'll mark whether it was redacted again, and then we'll log the sensitivity label ID for that specific summary. We'll build our view model for showing that actual table at the end, and then we will add the chat summary to our list of chat summaries and iterate through the loop again. So we'll turn these breakpoints off, otherwise we'll be here all day. And we'll continue till we get through these. Now this takes a minute to run. So in the background, it's doing that analysis. For every one of the chats that I have access to, it's making sure that I have the extract right. It's checking the label ID, and then building that summary. So it's making all of these calls over and over again to Azure OpenAI to build the summary output. And finally, what we'll get to once this finishes processing, and you can see it making a bunch of HTTP calls here, is building the final summary. So we've relied on the LLM to generate kind of a big picture of what the customer's concerns and attitude are. And we're going to ask it to summarize that into something that somebody can ingest very quickly and understand. So going into the next Copilot parallel, we need to compute inheritance. We need to figure out this final artifact that I'm generating, what sensitivity label should be applied. So the first thing that we do is we look at all of the chat summaries and we select the label IDs. So we just get a distinct list of label IDs. In this application, we're only using 2, so you'll just see 2 label GUIDs in this list. And next, we need to pass this into the information protection SDK to compute inheritance. So we'll call into our compute inherited label function. This is a custom function we've built. And what this does is it builds a list of matched labels that match my user policy. So it's going to check all the labels that are published to me as an end user, and it's going to build a list if this mouse over works. There we go. And so you'll see there are 2 labels here. So one is this all employees label that we've looked at, and the other one is the restricted data label. And these are, again, stored in my database, and they're specific to the end user. So next, to actually compute the inheritance, it's pretty simple. Each label has a sensitivity value, and that sensitivity value is from 1 to n. Take n. So whatever the max value is the most sensitive label, and that's what we should apply to the output artifact. Again, in terms of the discovered labels, not all labels. So we'll take those 2 labels that we found for all of our chats. We'll look at the max ID that we found for the sensitivity value, and we end up returning that label GUID. So we'll continue stepping, and we get back to the app, and you'll see that the inherited label ID is now that restricted data label ID that I need to apply. We then resolve that to the actual label object that we have stored in our database. And we will continue on now to build the final output summary. So here what we do is we join all of the chats together into one, or chat summaries into one monolithic summary. And we append sort of a system prompt to the end of that. And the details aren't important of the prompt other than if any of the chats say something like, sorry, I can't summarize some ID. We're expecting the LLM to take all of those and to build a summary out of that. So in the chat with Alice, you saw I couldn't show you message 127. This helps the LLM to generate that output for us in a way that makes the user able to understand what happened. So we'll run through this, send it off to Azure OpenAI, and much more quickly get a response. Now finally, we'll build the last chat summary. This is the one that the end user is going to see, where we have the final summary generated by the model, which I can mouse over here and you'll see I'm happy to help. We have the sensitivity label ID. Again, this is inherited from all of the conversations to the output. And then the references. We build this reference collection, and we attach that to the summary. We'll build the label picker. So this is just going to show the view model when we get into the application, or into the results. Add the messages, create the chat summary, and we return back to the application. So similar to the last experience, you'll see that this one finally gave me the output I wanted. It's very non-deterministic, so you never know during a demo what you'll get. First, we get the correct sensitivity label. So going back to the inheritance, we had a single chat that was restricted data. Now my output chat has that data. If I were storing this in my database, let's say I want to keep track of what my users are doing in terms of these summaries, and I'm creating an output of those, all of these chat summaries would be labeled as restricted data. So if Alice were to try to access them, she'd be denied. She would just see, sorry, you can't see that. So it helps to maintain that data protection, prevent Alice from relying on other people's summaries to get to this information. If we look at the output of the summary, you'll see why it was redacted. It's because, for some reason, our customer service rep asked for William's password, and he used his dog's name for the password. And so that was logged in the chat as well. And we want to make sure that not everybody can get to that. We would probably redact this anyway in a real-world scenario, but I think it makes it pretty clear as the type of information we're trying to protect. And again, if I scroll through the references, you'll see down at the bottom there's this highly confidential restricted info chat, which if we go and take a look at, you'll see this is where William shared his password with the customer service rep. So tying all of that back to Copilot, we've demonstrated the, actually let me go back to slides here. Closed it too early. We demonstrate that we get the label inheritance, that we're building these references that contain the labels on the referenced content, and that we're doing this extract enforcement to make sure that the user who's summarizing this data actually has access to that information at all. All right. So now we'll switch back to slides really quick. So as a wrap-up, tying this back to Copilot, we demoed here this customer service application that you could really model to anything in your organization. Any app that's using LLMs and anywhere that you have sensitive data to protect, you could use the same model that we've used in Copilot. It uses Azure OpenAI to summarize the data, but really this applies generically to any LLM. As long as you're passing data into some large language model and getting output back, you can apply these techniques everywhere. And then the pillars we discussed were showing sensitivity labels for sensitive data, preventing unauthorized users from accessing sensitive data at all. Applications should do this. The labels provide just another step, another layer in that defense. Prevent users from summarizing information that they shouldn't be able to summarize. And finally, we demonstrated inheriting the label to the output artifacts. Now, there's one gap in all of this, or several gaps, but one we'll talk about here today. Did anybody go to RSA? Review RSA? Different crowd? Right. So at RSA, we announced AI Hub. And AI Hub allows us to begin to audit events related to AI across your organization. So we can, for example, if somebody's using Copilot and sending prompts trying to maybe be malicious and inject things or collect information about the organization, AI Hub allows us to summarize that information and understand what's my security and compliance posture across AI in my organization for any LLM. The Purview SDK will unlock exactly that for your organization. So going back to the financial services baseline requirements, we found that they had a pretty strict set of requirements across all the Purview solutions you see on the right side. They had strict requirements around information protection, auditing, e-discovery, and retention. Some organizations were treating these chats as though they were actual real people chats. So they were, for discovery and for government regulation, logging them just the same way. So we had to do a lot of work leading up to the November Copilot launch to enable this. And we did that through each of the Purview solutions you see on the right side. So today we talked a bit about information protection and how to enable that in your AI-enabled integrated applications. The Purview SDK will unlock the last four. We'll give you audit, communication compliance, e-discovery, and data lifecycle management. So with just a few lines of code, which I will show you here shortly, it'll allow you to discover AI risks, better protect sensitive data in the future, govern AI usage globally, and we'll do that all through the Purview SDK, coming soon. And now we'll do a quick demo of that, which doesn't need to be live. So in the background, while we were doing this demo, and all of the data for my demo was generated by Azure OpenAI. So as I deleted my database and reran it, I had to sit there for 5 minutes and wait for everything to get generated. As part of that, we had integrated the Purview SDK. So I've got this OpenAI service, and I have this just send GPT request, which is my generic just call Azure OpenAI. Oh, sorry. Forgot we're on two different screens. So in here, we're in this OpenAI service, and this is just our library for calling into Azure OpenAI. As part of that, we've injected this call to send Purview audit, process conversation message async. And that happens anytime anything in the application calls Azure OpenAI. Totally transparent. We don't really wait for anything or care what happens, but fire this audit event off so that it gets logged. And this is live today. The AI Hub we released in preview earlier this month at RSA. And this is real data that's been sent by my application as I've been working. Guess which night I was working the latest on this. So we're going through this, and I can see by day activity. This is all the AI interaction traffic for my tenant generated by this application. And so as we click through this, we'll see Contoso Pets is the app. So in this case, this is a response from the LLM. And the data here is pretty limited. We're still doing a lot of work over the next several months to continue to light up scenarios and what you see here and feeding this into insider risk management and other places. We'll be able to click through and see which users were generating that interaction. So in this case, you'll see my admin account was in here. Actually, I think that's the only account I used. And we've done this all with a relatively simple-ish block of code here. So we create this process message request, add some request metadata about the client. We create message groups and a tenant ID so we know which tenant we're referring to. Create a message group. So in this case, we're saying it's Copilot auditing for our Contoso Pets application. And then we'll have some conversations in here. So we've got just two messages here. We take the prompt that the user sent. We take the response from the LLM. We bundle those into that as one message in the message group. We finish it off with just some app host information. So as we begin to include more information in AI Hub and auditing about this, you'll see some of these other fields appear. But in this case, you'd see the app URL and then the app name. We could optionally add more participants here. Get a token, and we send that off. And that gets ingested into into Purview AI Hub and do our auditing experiences today. These capabilities will continue to grow, moving into e-discovery, communication compliance, insider risk management, and data lifecycle management in the future. All right, so wrapping up. So key takeaways from today. We talked about how to use Purview to secure and govern data throughout its AI lifecycle. How enterprise apps should use that Copilot model. Like if you take that model that we put a lot of thought and feedback from these big, very secure customers and how they expected it to work, and if you apply that to your same, whether they're ISV applications, line of business applications, building that familiarity for both your enterprise app administrators and your users will result in quicker success. There's fewer barriers to get through, familiar admin experience, and all of that stuff's important in unblocking these integrations. You can use the Microsoft Purview Information Protection SDK, which is generally available now, been around for a few years, to get started with the information protection value. So everything I showed you today in terms of the labeling and the protection, you can do right now. So start today on that. And then finally, you'll be able to use the Purview SDK, which is coming soon, to build the rest of that story into your own apps. We've got some other resources here in the slides. There's other talks. I think one of these links should point to talks I've done in the past on the 425 show, and I think maybe Build, although that's been a while. So if you have questions on MIP SDK, you can check those out or ask questions during the Q&A. And other than that, check out the QR code for other sessions and resources, and we're happy to open it up for Q&A. Thanks, everybody. Yeah?
Just a quick question. If this is out of scope, no worries. Did someone have to go through each component of the chat and label it as restricted, redacted? Or are those labels auto-generated somehow, either through the LLM as the audit?
Yeah. So the question was, did somebody have to go through and manually update each of those labels? So in the sample application, you saw that we had labels on all the chats. Now, ideally, that would be done automatically. You'd have some either classification logic in your app that does this. One of the Purview components we're looking at is possibly providing some classification that can help you to do that and classify these chats and things as they're sent off to us. So we'll know that classification based on the contents. But for today, in the demo, you'd have to do it manually or use like Microsoft Presidio is a good example of something that could handle that. Thanks. Yeah? Oh, there's a mic coming.
So you had talked about authenticating the user when going through and checking permissions. I was curious, do you have to have all of the users in Entra ID or Azure AD in order to make that happen, or can we check against a different directory?
Today, the Purview sensitivity labels require an Entra ID identity. So, and we don't support guests today. So you'd have to have somebody who's part of your organization gets your organization's sensitivity labels, and then they'll be able to get that information. For the protection outcomes, we do support external identities. Like those users wouldn't be able to fetch a labeling policy per se, but you could certainly check their access level based on what you've defined in the label policy itself. An example of that is today you can take an email apply a sensitivity label and send it to somebody outside your organization, generally another M365 customer. And if you've defined them as having access, they'll be able to open it without being a guest or anything. You could probably apply that same pattern here, but as far as like, can that user list labels? Today the answer is no. Thanks. Other questions? No, yeah, over here.
Building on the first question, are there plans in the future to make it so that those labels can be?
Are there any plans to make it so that the labels can be generated by some AI endpoint where I can send the text and get back the label, and AI doesn't really remember the text I sent it, but I get the label back?
Yeah, so if we go back to, let me share this quick. Yeah. Did that switch? Oh, I hit the wrong button. Technology's hard. So one of the columns here, we didn't go through each of these, but is sensitive info type. So you wouldn't necessarily, in this case, this is good feedback though, as we're thinking through what this looks like. In this case, we would take that event that you sent us, we would do classification on the prompt and the response, and we would log it here. Today, I don't think we would give you that data back, but that's really good feedback and something that we'll consider as we build this out and grow it over the next few months. Thanks. Other questions? Awkward silence.
Any from the chat?
All right, well, thanks everybody for your time. If you have any questions, we'll be here for a bit, and yeah, have a great rest of build. Thank you.